Hi all, I'm going to go ahead and start with graphing versus substitution form A on this video. So I put a couple notes up here that you need to have already filled in your notes, but if you're missing them, make sure that you write them down. When we're talking about graphing, both equations should always start off in slope-intercept form so that we can find the slope, we can find the y-intercept, and then we can graph both lines, okay? When you're using substitution and you're going to pick one of the equations and you're going to isolate a variable, you can get it to be x equals or y equals. So look for the one that looks the easiest, and that's the one you should focus on. Okay, it's easiest when there's a 1 in front. Second to that would be a -1 in front of the variable. So once you have this step for one of the equations, then you are ready for substitution. Okay. So form A here, what we did on this one, I forgot to write something, but we did complete this one in class, okay? Both of these were already in slope-intercept form. So all I had to do was find the slope and find the y-intercept, right? But it will not always be that way. So I'm gonna go ahead and jump down to another graphing one, and I'm gonna go to number 5. Okay. So for graphing on number 5, again, they both need to be in slope-intercept form. So when I look at this first equation, it is already y equals mx plus b. So my slope on this one is +2, or we can write it as a fraction, 2/1. Our y-intercept is at 0, -4. Okay, so let's go ahead and graph those. So we've got starting at -4, and from there we're gonna go rise 2, run 1, rise 2, run 1, okay? If you don't have a ruler, go ahead, practice making these points so that we make sure we know where our lines are gonna meet, okay? Remember, this is always up to over 1, or right 1. However, there's the inverse where we could go down to left 1. Okay, so I could decrease 2, go left 1, down 2, left 1. Okay. Once we have those points, again, as long as you have a ruler and you have 3 points, you can go ahead and graph them. It's all about precision when it comes to graphing. Okay. All right, now the second equation. Okay, 6x minus 3y equals 12. That is not in slope-intercept form. So I have to get it in slope-intercept form, which means we have to get y by itself. Okay, so we are going to add or subtract 6x from both sides. Common mistake here, even though these cancel out, and we've got -3y. Oftentimes, people are wanting to combine the 12 and the -6x. However, they are not like terms because they don't both have the same variable. Okay, one has a variable, one does not. So this one is going to be -6x plus 12. Okay. Then we are going to still try to get y by itself. So we are going to divide by -3. And when multiplying and dividing, it's every term. So these will reduce to 1. So we've got y equals, negative divided by negative is positive, 6 divided by 3 is 2, so 2x, and then 12 divided by -3 is -4. Okay, now that's in slope-intercept form, so that now I can identify that the y-intercept, or I'm sorry, the slope is 2/1, and the y-intercept is at 0, -4. So graphing that one, starting at the y-intercept, 0, -4, and from here we rise 2, right 1, rise 2, run 1, rise 2, run 1. Looking at these points, I can see that my graph is going to be one right on top of the other. We did talk about this with graphing. when you have two equations that stack up on each other, that just means that they have multiple, many, numerous, infinite points where they meet up, okay? So this here is infinite solutions, okay? So your answer for this one is infinite. Okay. All right, now I'm going to go ahead and do number 4 with, actually I'm going to go do number 2. I'm going to do number 2 with substitution. Okay. So with substitution, I said one of the equations, you need to get one of the variables by itself. Okay, when I look at these two, I'm looking to see if any of the x's or y's has a positive 1 in front of them, which they do not. Then I'm looking at any of the x's or y's. Do they have a negative 1 in front of them? This one does. It has a negative 1. It's an understood 1 there. So that's the equation I'm going to work with. Okay. So we've got 5x minus y equals negative 5. I have to isolate the variable y. Okay? Or I could do x, but that might leave me with a fraction. So I'm going to go ahead and go with the y. So first off, I'm going to subtract 5x from both sides of the equal sign. On the left side of the equal sign, we've got negative y. And on the right side, we have negative 5x minus 5. Please do not combine those because they are not like terms. They do not both have the same variable. Okay. Now, y is still not by itself because it is actually being multiplied by a negative 1. Okay. So in order to remove that negative 1 from the y, or set it to a positive, we have to divide by negative 1. Okay, whatever I do to one term, when multiplying or dividing, we do it to all. Okay, so that would give me positive y, positive 5x, and positive 5. Okay. I am going to show you one other thing here before I move on. I'm going to leave the answer there. Okay, but I want to delete some of this here because I want to show you I can either divide by negative 1 or I can multiply by negative 1. Okay. Negative 1 times negative y would give me a positive y. Negative 1 times negative 5, or negative 1 times negative 5x gives me a positive 5x. Negative 1 times negative 5 gives me this positive 5. Okay, so you can either divide everything by negative 1 or multiply everything by negative 1. And the reason that I like multiplying is because when I multiply by negative 1, that is the same thing as it's going to change everything's sign, because a negative times a negative would make this a positive. A negative times negative 5x would make that a positive, and a negative times a negative 5 would make that a positive. Right? All right, first thing we said we had to do was get y by itself. We did that. That's the first equation that we're working with. So now that y is by itself, I am going to take the equation part. I'm going to plug it into the second equation, which I haven't used, in place of y. So we're going to have 3x. I'm going to put this line here so it doesn't look like one problem. 3, or I can put parentheses, minus 6. Oops, did that wrong. I didn't draw for x. Sorry. So we have 3x minus 6, and instead of y, I'm going to put an open set of parentheses and a closed set of parentheses, equals 24. Okay, that is the actual equation. But instead of putting in y, we are putting in 5x plus 5. So we are plugging that value in. We're using substitution here, substituting in what y equals. Now the only equation, or the only variable left is x. So we are going to solve for x. So we've got 3x, negative 6 times 5x is negative 30x, and negative 6 times positive 5 is negative 30, equals 24. These two here both have the same variable, so they are like terms. So 3x minus 30x gives me negative 27x. Okay. Then we are going to add 30 to both sides. And I have negative 27x equals 54. Divide them both by negative 27. And we get x equals negative 2. Okay. Again, that is the piece that's going to take the most work. This next part will be pretty simple. So of my answer, I know the x value. If you were solving for y, you'd know the y value. Okay. Now I'm going to take x equals negative 2, and I'm going to substitute it in to one of the original equations, whichever one looks easier. 5x minus y equals negative 5, or 3x plus minus 6y equals 24. To me, the one that looks easier is the 5x minus y equals negative 5. Okay. If you use 3x minus 6y equals 24, you will get the same solution. Okay. Now, instead of x, so instead of x minus 2, instead of x here, I'm going to plug in negative 2. So then I have negative 10 is equal to y minus 5. Add 5 to both sides. And I get y equals negative 5. Okay. There's one ordered pair, which means there is going to be one solution. Okay. All right, that is it for the A video. If you have any questions, please reach out to me. Otherwise, make sure you have this ready with either questions or something to review or check your answers with your partner tomorrow.